All right, guys, we're looking at 3 merit questions from 2012. All right, so first up, you've got z cubed plus p equals 0, and they're letting you know that p is a positive real number. And I think this is quite important that you actually understand why this is, because if p is a negative number, then yeah, it could just mean a different thing. But look what happens when I write this up. So I've got z cubed equals minus p. That's my first step. So when I actually draw z cubed, just minus p in a complex plane, minus p, because it's a real number and it's p is positive, when you have negative p, it's going to become a negative number. So this is where negative p is. All right. So because negative p is here, its modulus, which is r. R in this case is just going to be p by itself because that's the length of the complex number. And the angle that I'm looking at, or the argument is going to be 180 degrees. Is that right? So I could write my first step here, z cubed equals, writing minus p in r cis theta form, I'm going to get it as p cis 180 degrees. So applying De Moivre's theorem, I'm going to have p cis 180 degrees to the power of a third. So my first root is going to be p to the power of a third cis 180 divided by 3, which equals to 60. All right, so that's my first root. Now, because it's 3 roots, what am I adding to each one of the roots? What angle am I adding? 120, because 360 degrees divided by 3, that's going to give me 120 to add to each one of those roots. So z2 equals p to the power of third cis 180 degrees. And then z3 equals p to the power of third cis 300 degrees. Is that okay? Any questions on this? Now, in terms of achieveds and merits, I think you need all 3 roots for merit. And for achieved, in this particular paper, achieved is getting to this stage here, converting it into r cis theta form or polar form. Is that right? Questions? The silence is killing me, but anyway. Okay, we'll go to the next question then. They've asked you to find dy dx, which is for a curve that's defined parametrically. Now, I talked to you guys about this before. You guys already know how to do this. And we kind of did one example, but I'll show you guys how to do this one here. So with this, remember that you're trying to find dy dx. Looking at that first equation where you have x in terms of t, if you differentiate it, you're going to get dx dt. And if you look at the second equation, which is y in terms of t, if you differentiate this one, you get dy dt. All right? And just remember that I'm trying to figure out dy equals to dx. So we know that we could actually find dy dx by doing this, because dy dt, I can write it like this, and of course I multiply this with the inverse of dx dt, which will be dt over dx. All right, that's how I find dy dx. So let's work out dx dt first. So dx dt is going to equal 4 cos t squared plus 1 multiplied by the differentiation of whatever is inside the bracket, which is 2t. And this could be simplified as 8t. Get rid of this. 8t cos t squared plus 1. Is that all right? And as for dy dt, I can write that as dy dt equals negative 3 sine 2t minus 3 multiplied by the differentiation of whatever's inside the bracket, which is 2. So I can rewrite this as minus 6 sine 2t minus 3. Straightforward? Yeah? Now, I think if you do one of these derivatives correct, you get achieved. But to get to a merit, you just, in this 2012, you just have to put them together. So basically, I can write dy dx is equal to dy dt, which is minus 6 sine 2t minus 3 multiplied by dt over dx. So that one, I just write it down as 1 over 8t. I need some more space, hold on. 8t cos t squared plus 1. Okay, and you can leave your answer like this, guys, and that's basically it for this question. That's your merit right there. Okay, so merit to get to here, and if you do one of the differentiations, one of them, you're looking at an achieved. Questions? Straightforward? Yeah? All right, let's go to the next one. So with this question, with this integration question, you're asked to find an expression for the shaded area in A. So the first thing you really want to be doing is you've got to figure out what this point here is, the purple point here. All right? To do that, you've got to put both of those equations together. Now, your first equation is, what have I got? Y equals to x over a squared. Have I got a second equation? This one here. And the curve y equals a over x squared. Okay? And if I put them together, what happens is I'm looking at both of those equations. So this one here is y equals x over a squared. And the curve here is y equals to a over x squared. All right? So because both of the y's are the same, and if I put them together, I get x over a squared equals a over x squared. Cross multiplying this, I get x cubed equals a cubed. Therefore, x is equal to a. So I've just figured out what the purple point is, and that purple point is a. Now, if I was to work out, let me see if I can try and do it like this. If I want to work out the area, I'll look at my two values that they're between. So I've got it between a and 1. And do you guys remember how we find the area between two curves? Yes, it's definite, but there was a particular formula for it. Which equation do you put it first and which? Yeah, so it's like the top equation minus the bottom one. Bottom equation? Yeah, no, not in this stage. So we've got this equals between a and 1. The top equation in this case is a over x squared minus the bottom one, which is x over a squared dx. Is that all right? So I'm going to write this in one more step before integrating it. So I'm going to write this as ax to the power of negative 2 minus x over a squared dx. So when I integrate this, I'm going to end up with ax to the power of negative 2 plus 1 divided by negative 2 plus 1 minus x squared over 2 times a squared. And this is between a and 1. So far, so good? Now it's just a matter of substituting everything and simplifying it. Let me see if I can try and squeeze this in. But I'll simplify the equation first, so it just makes it a bit more easy for me. I could write this as a negative 2 plus 1 is negative 1. So I can bring it to the denominator. And then this negative 2 plus 1 means there's a negative 1 at the bottom. So I can just leave it as that. And then on the other side, I've got minus x squared over 2a squared. And that's between a and 1. So substituting all my a's in 1, I get negative a over a minus a squared over 2a squared minus, what have we got? Negative a over 1 minus 1 over 2a squared. Is that okay? So simplifying this, I've got negative 1 minus a half minus negative a minus 1 over 2a squared. Okay, now I can't simplify this, and simplifying this, I'm going to get negative 3 over 2 for this bracket. Here I'm going to get plus a plus 1 over 2a squared. And there you go. That's basically it right there. Can't do any simplification any further than that. I mean, you can if you want to, but I've left my area in terms of a. Okay, so merit up to here. Achieved is when you do your integration there. Any questions? No, we're good. Bit of a surprise look here, but thank you for participating in today's very quiet session.